Okay, guys, in this part of the lesson, we're going to take a look at two more possibilities of solution sets. Remember, we are trying to isolate x so we can see what the unknown value is that will make our equation true. Meaning, once we find the value of x, we can plug it in, use the order of operations, and the left side will equal the right side. In this first problem, we need to apply the distributive property. We're going to multiply 2 to get 2x plus 2. On the right side, we're going to combine like terms. Remember, the operation in front of the term belongs with that term. So this is negative 3 plus 5. Now we have variables on both sides, so always address the variables, not the constants first. So here we can see that we typically would get rid of the smaller variable, but these are both the same. So we're going to subtract 2x, and the variables are going to cancel all together. And we have 2 equals 2. So we don't have a variable equal to a value. What this tells us is when our variables cancel and we end up with a true statement at the end of solving, this means there are infinite solutions to this equation. This means any real number could be plugged in for x here and here, and the left side will equal the right side. So any value will make the equation true. Let's take a look at this example. We have an understood negative 1 that we need to distribute, and this is going to give us negative 1x minus 2 minus 5x equals 2 minus 6x. On the left side, we're going to combine negative 1x and negative 5x. That gives us negative 6x minus 2 equals 2 minus 6x. So we just combined our x terms. Now we have variables on the left, variables on the right. We notice they are the exact same term. We need to make them cancel, and so we're going to add 6x to both sides. Again, typically we would be getting rid of the smaller variable term, but in this case they are the same. I'm going to bring down my negative 2 equals positive 2. So in this case, our variables canceled altogether, just like in the previous example, but this time we ended with a false statement. When we have no variables left with a false statement, we say there is no solution. There is no value that if I plug in for x here, here, and here, will a value make the left side of this equation equal the right side. So now we have infinite solution possibility, a no solution, and then the one that we've had up to this point, which is one solution. So I encourage you to pause the video at this time and write down this chart. You can see that when you have one solution, like we're used to doing, we solve the equation and we end up with x equals some number. So when you get an ending statement such as x equals 7, this indicates there's exactly one solution. We know 7 plus 3 does equal 10. In our next column, infinite solutions, when we solve the equation, we end up with a number equal to itself with no variables at all. This indicates that any value will work to make the equation true. So x can be any real number. We have infinite solutions. So when you have something like 7 equals 7, this tells you there are infinite solutions. And then finally, when we have no solution, the variables cancel and we end with a false statement, such as 7 equals 5. This indicates that there is no solution to this equation. The left side will never equal the right side. So let's practice a few of these and describe the solution set as either having one solution, no solution, or infinite solution. This is just the infinity sign. Okay, so let's write this problem down. Let's simplify it. So on the left side, we can combine -8 plus 12. On the right side, we can combine 1x plus 2x. We have variables on the left and the right, so remember, address the variables first. Don't be tempted to subtract 4 from both sides first. Let's get the variables addressed. So we're going to subtract 3x. We notice that the variables are going to be eliminated. We have a +4 equal to a +4. We have no variables. We have a true statement, so this is infinite solutions. Any value will make our equation true. Okay, in our next example, we have to distribute 1/2. Multiplying by 1/2 is the same as dividing by 2. So half of 8x is 4x. Half of -12 is -6. We're going to distribute 2. We get 8x minus 6. We have variables on both sides. This time they are not the same. We're always going to get rid of the smaller variable term first. This is a -6 we're going to bring down. We are now solving for x. We're isolating, so we have 8 times x minus 6. We're going to add 6. We have 0 on the left. 0 is a value, so don't just stop there. We're going to undo the multiplication by dividing by 8. We can have 0 divided by a number. You just can't have 0 in the denominator. So my one solution is 0. 0 is the value that's going to make the left side equal the right side. So we're going to describe this as exactly one solution. And that one solution is 0. Okay, in this problem, we need to distribute on the left and on the right. And just remember, you can pause the video at any time. So we're going to distribute the 2 and get 2x minus 8 equals, we're going to distribute the 4 and we're going to get 4x plus 24. We have variables on the left and the right. We're going to subtract out the smaller one. We're going to bring down this -8, so always be careful about the operation in front of your term. We're going to isolate x. We're going to undo the addition first by subtraction. We're going to undo multiplication by division. And my one solution is -16. This equation has one solution, and that solution is -16. Okay, let's solve this one. We're going to distribute 1/3. 1/3 is a unit fraction, meaning 1 is our numerator. So when we're multiplying by a unit fraction, such as 1/3, 1/2, 1/4, that's the same as dividing by that denominator. So 1/3 of 9 is 3, and that's 3x. 1/3 of 12 is 4. Over here, we're going to distribute the 3, and we're going to get 3x minus 12. We're going to address the variables first. They're the same, so we know they're going to cancel, so we're going to subtract them. This is going to give me a +4 equal to a -12. We have no variables with a false statement, so this equation has no solution. Okay, let's do a couple more. We are going to distribute the unit fraction of 1/4, so that really means we're dividing by 4. So we're going to get 2x plus 4. Okay, 1/4 of 8x is 2x, 1/4 of 16 is 4. Equals, we're going to distribute the 5, and we're going to get 5x minus 10, and then minus x. Let's bring down 2x plus 4. We're going to combine the 5x minus 1x, that's 4x minus 10. We do have variables on the left and the right. They're not the same, they're not going to cancel, so we're going to address the smaller variable and remove it from the left side by subtraction. We're going to bring down positive 4 equals 2x minus 10. We're going to isolate x by undoing subtraction first, the opposite of order of operations, and we get 14 is equal to 2 times x. We're going to undo multiplication by division, and my one solution is 7, so we'll describe that as one solution. Okay, in our next example, let's distribute this understood negative, and we get negative 3x plus 6 equals, let's distribute 3. We get 3x minus 12. We have variables on the left and the right, but this time they are different. So this is a negative 3x, so we're going to move the negative 3x by adding that whole entire term, making it go away. We're going to bring down positive 6 equals 6x minus 12. We're going to undo the subtraction first by adding 12 to both sides. We're going to undo multiplication by division. And my one solution is x equals 3. 3 is the value that will make the left side, once we plugged it in, equal the right side. So let's describe it as having one solution. And I hope this helps.